Hello everybody. My name is Ewan Rule and I work for Petrosys in Glasgow. Thank you for joining us today for today's Petrosys webinar, which is in mapping standards and why they matter. Please note that this webinar will be recorded and I'll be pleased to take any questions or feedback at the end. And if you want to get in touch with me, if you have any thoughts after the event, you can see my email address is there in the bottom left, or else feel free to get in contact with your local Petrosys office. So we'll start off today with a PowerPoint discussion on the mapping standards, and then we'll do a demonstration within our software showing how the end user can apply these standards. We're not going to be focusing on how you set them up in Petrosys, just how you actually use them as a geoscientist. And then we'll finish off by summarising the key points at the end before the feedback and questions. So before we look at the mapping part, we'll just consider what we mean by a standard. So these definitions are from the Free Dictionary. So what is a standard? Something such as a practice or a product that is widely recognised or employed, especially because of its excellence. A set of specifications that are adopted within an industry to allow compatibility between products. Standards will vary in different geographies and between organisations. This doesn't mean that one standard is necessarily better than another, but there will be differences. Over an entire exploration and production workflow, there will be different standards for different parts of the process. But one thing they will have in common is that they will all be aiming to enforce consistent, high quality. Considering mapping standards, not everyone will have mapping standards in place, but many government agencies do, and so do many private companies. Sometimes this will be for topographic mapping, but some places will also have mapping standards for subsurface mapping. There are a whole range of organisations around the world who have these standards in place, and it's always worth checking whichever jurisdiction you're in to see what is recommended. When submitting projects for internal budget approval, for partner review, or for government approval, it's essential to present data clearly and attractively to give the other party confidence in the quality of your work. Maps are universally understood, and the same sort of geological features are found the world over. Standards will often not be the same between national jurisdictions. However, there are also many international standards, and they're increasingly common as it makes sense to use the same symbology that is understood by as great an audience as possible. Just as an example, if you are moving location between one country and another, it makes life a lot easier if a dry hole symbol is the same or the symbology for a thrust fault is the same. And on the IOGP website, you can also find a standard legend, which is always a good starting point if there isn't anything else in place. To reiterate why mapping standards are desirable, geospatial data lends itself to a map. A clear and informative map should be easy to understand and evaluate. For the map consumer, this should mean less time trying to work out what the map is showing and more time concentrating in the map's message. This in turn should lead to better informed decisions as you're spending time thinking about the data and not trying to work out what it's showing you. Map standards also promote consistency. This makes it far easier for decision makers to compare data in different assets in different geographies. And at company level, it also helps to strengthen corporate identity and associate it with good quality. In the bottom right here, it's not particularly obvious, but there are actually big differences in things like the way the faults are displayed here, the well symbols. Just essentially, we've got the same data here mapped in two different applications, and they look significantly different, which we want to avoid if we can. Now, have mapping standards been maintained? Hopefully in the organisation you work in, they have been. Many organisations continue to produce robust and reliable maps, but perhaps there are reasons why standards aren't quite as good as they were some time ago. When the oil price started to rise rapidly in the early 2000s, investment was flooding into the industry. I think the oil price got to a peak of just under $150 a barrel. There were also a lot of new staff taken on at this stage, and technical teams were under pressure to complete projects faster. Sometimes this was at the expense of technical quality, and inevitably this sometimes resulted in standards slipping. There are studies that suggest there is a direct correlation between the oil price and the discovery rate, and the discovery rate tends to be higher when the oil price is low. And it's pretty clear that one reason for this is there's much greater technical scrutiny. When budgets are tight, you need to have a higher success rate, and mapping standards will help with this. Now, after the oil price peak, the price went down again, the usual volatility we're used to in the industry. And in times of cost saving, it can be very attractive to reduce the range of software that's available and try and do everything with as few applications as possible. This can involve balancing cost saving against reduced quality and more time spent trying to improve in suboptimal outputs. I often hear people saying that their maps are good enough, and sometimes they are. The person making the map is likely to be very familiar with their own data and able to interpret the map quickly. However, it might not be the same when they start to show it to other people. And finally, many of us have been working from home over much of the last year, and it remains to be seen whether we'll all go back to working in the office all week as we did before. It's much easier to forget about company standards or just accept the software defaults if you don't have a colleague to give you a friendly nudge back in the right direction. And this too leads to variation in the way maps are made and presented to managers. And I've just got a map here on the right that shows some of the sorts of issues which you want to avoid. Things like having peculiar scales in your map. We've got some strange looking faults. Terrible overposting. It's really not very clear what it is that you're trying to get from this map at all. So at the end of the day, who benefits from map standards? Everyone. So you'll benefit, so will everybody else looking at the map. And when you're making it, always consider who the map consumer is going to be. Is it just for your own purposes? Almost always you're going to want to share it with other people, and you need to consider things from their perspective and what they're trying to get from your map. At the start of the project, you're mainly going to be gathering data for assessment, and quick maps might indeed be good enough. However, the sooner you apply standards, the better. It will make it easier for you to make comparisons with previous projects you've worked on, and that in itself may lead to faster insights. Sooner or later, you're going to want to share your map with others, and they need to be able to quickly understand the map too. So by this stage, you should already be aiming for a high quality map. For individuals, you'll make your own life easier and your interpretation better with clear maps. Furthermore, you'll be more influential with your peers and managers. This can both save you time and help expand your career opportunities. Managers and investors never have enough time, so anything you can do to make it easier to understand the interpretation will be greatly appreciated. It's much easier to make investment decisions if they're justified by clear, high-quality technical work. What sort of things are we talking about in these standards? There are all sorts of different aspects that can be standardised in the map making process. So just some examples here, we can have things like standard colour gradients, perhaps using perceptual gradients to represent the data more accurately. Consistency in well symbols is vital to avoid misunderstandings. Regardless of the data source, whether it's coming from GIS data, from interpretation systems, you want your well symbols to be consistent across all of them. Meaningful fault ticks are also a great aid to geological understanding. In some jurisdictions, there are standard colours to represent different fluid types in fields and pipelines, and possibly standard colours for different licence operators. The map frame is also important, so the part out with the data. How are the coordinates displayed? Do you have eastings and northings and lat longs? Do you need them? Do you have elements like the scale bar, a legend or a location map? And last but not least, always remember your coordinate reference system. So in most areas there will be a preferred CRS. The EPSG can be an excellent reference for this if you don't have in-house company advice. There can at times be reasons to use an alternative coordinate system, but be very sure that you've got a good technical reason for that before you change. And although we won't really look at it today, when you're working with Petrosys, when you connect up to applications like Petrel or Decision Space, we'll pick up the coordinate reference system of your interpretation project automatically. So we'll now move into a live demo within Petrosys and see how we apply some of these aspects. So I'm starting off here with a very basic map. If you've just installed Petrosys out of the box, if you're evaluating the software, this is what our default map style looks like, which isn't itself, it's quite basic. It's got XY coordinates, it's got a scale bar, not too much more. And all I've got displayed at the moment are a surface and some wells. And these are coming directly from Petrel. I've dragged and dropped them into my map for display. And the first thing to note is that you can see that we're picking up the Petrel colour bar automatically. And also, if we look at the wells, we're also picking up things like the well path colour, top colours. They're automatically coming in the Petrel symbology too, with the Petrel colours. So you don't need to spend time setting these things up in Petrosys. We're already giving you consistency with the interpretation system that you're working with. You can see we're also picking up the well symbols correctly here. So there's very little work involved in getting things to appear consistently. Now, of course, in Petrosys, we're trying to make things look better. We're trying to make the maps better. So I'll just quickly make some edits here to improve what we've got. We'll make our fault polygons opaque, and an important thing is just to put on some fault symbols so we can see the throw of these faults and start to get more meaning from the display. We'll just add in some contours as well. We'll label these, and you can see that the contour label is being picked up automatically from the depth domain of the grid that's currently displayed. So the depths are going to be in meters. And now we're already starting to lose things like the well names, which are probably quite an important thing in the map. So we'll just make the well annotation opaque, and that will make it much easier to see those again. Now, we're talking about standards and styles. As I said, this isn't a particularly useful or attractive style that we've got displayed here. So on a site, you can set up map styles. So somebody that's a Petrosys expert can set up a small group of styles for everybody else to use in certain contexts. So if I wanted to put this map into a PowerPoint, I might select a style like this. And the advantages of this are that it's got the coordinates in the inside of the map frame, which means we're maximising the area for our actual data display. If we zoom in down in the bottom here, you can see that we've still got a scale bar. It doesn't have the actual map scale, it's just got something we can measure off. So if we put this into a document or a PowerPoint, or we just take a screenshot, this will still be valid for taking measurements. And also, importantly, it's got the coordinate reference system. So these coordinates are unequivocal, and in future someone would always know exactly where the data was in this map. Now at the moment, the area of interest is defined by the data that's displayed with a buffer around the outside. You might also want to apply standards for areas of interest for extents. So you may always want people displaying data over the same field or the same license block with a consistent extent. These can be set up too, so I'm just going to select this extent over the Gulfax field. And one of the things this does is it gives us more rounded coordinates at the map corners, which cartographically just looks a little bit better. Now, another feature of the Petrosys mapping itself is that we can display log signature maps. And I'm going to put a gamma ray on here. So we'll display this down the hole. We'll put on the well name in the log signature. Maybe just go from a particular formation. We'll go from the top Tarbert. So this is selecting the data that we want to display in the log signature. If we just accepted the default here, we would have what we see in this little preview panel. We would just get this blue line with the scale that's shown there. But you can also set up templates here for everybody to apply, so they don't have to spend time modifying the layout or style and getting it to look the way they want it to. So just select a pre-existing style here. And when we say OK, just take a moment, and then those log signatures are displayed in the map. Now again, I don't really like where they are. As you're probably aware, all the text within a Petrosys map can be repositioned, resized or hidden, so you don't get overposting. You don't get bits of text obscured that you don't want, or indeed you can highlight text if you need to. We could move the text around, but we can also do overposting with the log signatures themselves. And I'm just going to select all the ones we have displayed. We'll align them over to the left, and then this option here just lets us space them a bit more evenly. Drag them up here so they're not in the way. And then if we just zoom in for a moment just to see what the template looks like for the log signatures, you can see we've still got the well names, so we can match them up with the data in the map. And this particular template's got the depth, the tops, and then we've got a gradient displayed for the gamma. Obviously, we could have more log tracks in here, resistivities and other things, if that was what we wanted to do. But again, the idea is that you've got that consistency whenever different geoscientists and different projects are displaying their logs on their maps. So I'll switch off the well layer here. We'll also just switch off the contours for a second. And what we'll do next is we'll move away from this field level map and we'll start to look at this Gulfax area in a more regional context. So very often you're going to want to combine your project geoscience data with cultural information, or perhaps with key surfaces, corporate well databases where you've got company approved top hole locations or company approved tops. So I'm going to change my extent and we'll go out to the Viking Graben. And we'll just see where Gulfax fits in this larger area. At the moment, it's not telling us very much, but we can also apply what we call base map templates. So these are not shipped with the software, they vary in different geographies, but they can be set up at each individual site to show exactly the sorts of data that you want to be shared between the geoscientists working in your community. I've got a range of different base maps here. I'll just choose this one called NPD Fact Maps. So this is data from the Norwegian Petroleum Directorate. Now, essentially, this is just a Petrosys DBM file that's been saved to a central location. And all it takes is one individual to set things up the way they want, with the symbology they want, and then everybody can share that without having to waste time setting things up, or worse, not taking the time to make things look consistent and just going with the defaults. So as you can see here, the base map's split into different folders. We can switch all of these individual layers on and off. If we didn't want the development wells, we could just get rid of those, put them on again. We don't have any of the seismic displayed, we could have that on. And the different data types that you can have in one of these base maps, GIS data like shapefiles, data coming in from ArcGIS server or a WFS. You could also include Petrosys grids in here, so if you did have a regional surface, it could be in there. Or you could have well data coming in from a corporate database such as DBMap. So the end user can switch these on and off, choose whichever layers they want to add to their map. And of course, you can just drag it down to the bottom and your geoscience data will still appear in top here. If I was working in a different field down here, maybe if I was working in the trawl area, obviously all of this background information would remain the same. And another nice thing about the base map templates themselves, if you're working with things like shapefiles, then obviously you can query the attributes. If we just go between these different orange license polygons, in Norway, the operators have got different colours associated with them, and the orange is just everything to do with Equinor, so that includes the older licenses from people like Hydro, Saga, and so forth. Now we've still got our PowerPoint map style displayed here. If we were working with a larger area, there may be reasons why we would want to print out a hard copy map, maybe to put it up in the office or send it offshore. So I'm going to switch over to a different map style, just to get over again how easy it is to change the appearance of your map to have consistency without any work in the part of the end user. So this map style has got both lat long and XY coordinates. In this case, we've got a corporate title block. We've again got our scale bar with the coordinate reference system. In this case, if we're plotting out to hard copy, it is useful to the map scale, the north arrow. And also up here, we've got a location map just showing us where the Viking graben is between Norway and the UK. So things like this can be customised on site. You could have whatever you want in here for your location map or for the different elements within this map style. So hopefully you've seen how the styles, the base maps, the log signatures, they do need to be set up for each site, but once they're in place, they make it very quick and easy for the project geoscientists to create cartographically high quality maps with very little effort. And importantly, this leaves them more time to spend on their interpretation and making that look as good as possible. We'll just switch over to our PowerPoint again to conclude. Implementing map standards will improve the technical quality of your work. It will save you time and it will reduce errors and also misunderstandings. And really what we're trying to do is make sure that your data tells the story that you want and helps you to achieve your goals. And we'll just finish with a quote. Maps remain an integral way to understand geological knowledge, both for interpreters and investment decision makers. So don't accept maps that are good enough. It shouldn't be difficult or time consuming to create good quality maps of your data. And these styles and templates will all help with that. So I would just like to thank everybody for their time today.